All right, so you might remember when from the graphing section, also we've talked about it in, I think, with elimination and substitution, that there are three possibilities. You can have one solution to an equation, and that's what we had in the last example. Or you could have no solutions, or you could have infinite solutions. So I showed you what it looked like when we had just one solution. That was the last example. Now I want to show you what would it look like if you had either infinite or no solutions, and how can you tell the difference. So let's do the same thing. Let's pick a variable to eliminate, and I'm just going to pick x again because I see here that there's a 6 and there's a -3. Those are easy to change into a common denominator, common multiple. So let's use the second and third equations. I'm going to multiply this one by 2. So when we distribute that, we'll have -6x, 2 times 3y is 6y, 2 times 3z is -6z, and 2 times 18 is -36. The top one stays the same. Okay, and now let's eliminate the x's by adding those two equations together. So when we add these together, let's see what we get. So 6x plus -6x is 0. -6y plus 6y, that's also 0. 6z plus -6z, that's also 0. And -30 plus -36 is -66. So obviously we have a problem here. We're ending up with 0 equaling -66. And my question for you to think about is that ever possible? Could 0 ever equal -66? And of course the answer is no. So if you had to guess, is this going to have infinite solutions or is this going to have no solutions? And the answer is it's not going to have any solutions because 0 never equals -66. These lines right here, by the way, if you were to graph those on a 3D, I haven't shown you what that looks like, but a 3D coordinate plane would look like this. They put the x right here and they put the y right here. So it's almost like it's hard to draw this on a 2D page, obviously, but it's almost like you're standing up here, let's say, and you're kind of looking down at the x and y axis. And that means this one that's coming out of the page would be the z-axis right there. So on this graph, I'm not a very good artist. I'm not good enough to draw this, but on this graph, you'd basically have, instead of lines that were not intersecting, instead of parallel lines, you would have parallel planes. You'd have like a plane right here and then a plane somewhere back here, and there's all this space between where they never intersect. So that would be no solutions. What would infinite solutions look like? If you had done that same problem and instead you had gotten 0 equals 0 or 8 equals 8 or -66 equals -66, something that's always true, that's an example of when you would have infinite solutions. When something is never true, you have no solutions. I hope that distinction makes sense. And that is how you solve systems of equations using three variables.